Brakes, a presentation by Jisam Ahmed. I'm a civil engineering student of Alia University, and I give a presentation on the topic of brakes. Contents. Here we will discuss some basic concepts of brakes. Introduction, classification of brakes, composition of good brakes, properties of good brakes, manufacturing of brakes, testing of brakes, defect of brakes, special type of brakes. Introduction. The artificial material of construction in form of a clay or uniform size or shape are known as brakes. This is the basic definition of brakes. Man used these brakes since several years, more than thousands of years, and at first, the world used the brake in 7000 BC before Christ. The standard size of a modular brake is 19 into 9 into 9 centimeter. But on the other hand, the size of nominal brake with motor is 20 into 10 into 10 centimeter. The average weight of a brake is 3 to 3.5 kg, but it varies for different types of brakes. Classification of brakes. We broadly classified the brake into 4 categories. The first of one is first class brakes, second of one is second class of brakes, third is third class of brakes, and fourth is fourth class of brakes. Now we will discuss the first class of brakes. Here we will discuss some basic points, that is characteristics of first class of brakes. In a table, moduled and well burned in clings. It should be well burned. The first class of brakes. The color of the brakes will be deep red or cherry color. It should have uniform appearance and texture. Smooth, rectangular and parallel and sharp edges are some characteristics of a good brake. Should not break when it is dropped from a height of 1 to 2 meter. Metallic and ringing sound should be done when stuck with each other. The brake should absorb 12 to 15% water of its dry weight, and it should not exceed 20% of water if the brake is immersed in 24 hours in a water. The crushing strength of the first class brake should be 10 Newton per millimeter square, and this first class of brakes, we used this type of brakes for construction of exterior walls, interior walls, flooring, etc. Now we will discuss the second class of brakes. There are some basic characteristics of second class of brakes. That is, it is ground, moduled and burned in clings. It is rectangular in shape, but slight irregularity is permitted in the second class of brakes, but the slight irregularity is not permitted in the first class of brakes that we see. And the surface may be slightly uneven. It's okay in the second class of brakes. Metallic and ringing sound when stuck with each other. This is one of the most important point for first class and second class of brakes. Crushing strength should be greater than 7 Newton per millimeter square. Water absorption is 16 to 20% of its dry weight, but it not exceed 22%, and when immersed in water for 24 hours. This type of brakes we used in for RCC work and all that. Now we will discuss the third class of brake. The third class of brake is, there are some basic points or characteristics you can say. It is ground moduled and burnt in claims, but it is poorly burnt and overburnt, and it will become reddish, not deep red. The color will be reddish and soft, and its edge is irregular, distorted or rough. And if we stuck to bricks, then it produces a dull sound, not a metallic sound, as like first class or second class of brakes. Water absorption should be 22 to 25% of its dry weight, and crushing strength should be 5 Newton per millimeter square. The fourth class of brake. These are overburnt and hence dark in color and badly distorted in shape and size and brittle in nature. We don't use this type of brakes Rather, we prefer first and second class of bricks for other uses of bricks. Now, we'll discuss the composition of a good brick. What the things we need to make a good brick. Wow. But you can say, what is the good elements that have to present in a brick? That is, some elements are silica, alumina, lime, iron of oxide of iron, or you can say iron oxide, magnesia, alkynes. Okay, now we will discuss all of them in detail. Silica. Silica is an important composition of a good brick, and in a brick it must have a percent of 50 to 16% silica must be present in a good brick. Function: it absorbs water and provides durability. It prevents cracking, shrinkage and warping of raw bricks. It reduces shrinkage during burning. And if the silica the excess amount of silica is present in a brick, then what happened? It destroys cohesion between particle and brick becomes brittle. So it is, if the silica is greater than 60% or more than 60%, you can say, then the brick should be brittle and it is not a good quality for brick. But rather the percentage of silica must be 50 to 60% in a brick. The next one is alumina. The percent of alumina must be 20 to 30%, and the function of alumina is it provides plasticity and helps in molding. If we use the alumina in excess amount, that is the greater than 30%, we use the alumina, then it causes cracking and warping or drying on burning. Lime. The lime percentage must be less than 10%, and the function of lime that we use to produce a brick is it prevents shrinkage on dyeing or fusion. But if the lime is in excess amount, that is, if we use the portion of the lime is greater than 10% in a brick, then it causes brick to melt and hence brick loses its shape and we produce irregular bricks. And the fourth one is iron oxide or oxide, you can say oxide of iron. The percentage should be less than 7% of the total amount of element. The function is improves impermeability and durability, and it gives the red color. The iron oxide gives the red color to the bricks, and if it presents in excess amount, it causes cracking, it causes wrapping on drying. Magnesia, its percentage should be less than 1%. It have to be present, but it in less than 1%. The function, it imparts yellow tint and reduce shrinkage. This is the main function. It reduces shrinkage. But if the percentage of magnesia is greater than 1%, that is, if the magnesia is excess amount in a brick, then it causes cracking, wrapping, or dyeing. Now, what is the properties of a good brick? These are some concepts. These are some topic. These are some points. That is the properties of a good brick: size and shape, smooth, rectangular, parallel and straight and sharp edges. Color: uniform, deep cherry red color. This is the color of a good brick. Texture: rough, so that mortar sticks properly. Hardness: when scratched with fingers, nail, it should not make any impression. Soundness: metallic and clinching sound when stuck with each other. Water absorption: not more than 20% of its dry weight when it is immersed in a cold water for 24 hours. Crushing strength should be greater than 10 megapascal. Brick earth should be free from stones, grills, pebbles, etc. and also any alkali materials. Manufacturing of bricks. There are some basic steps that we follow to manufacture a bricks. The first one is preparation of clay, that is brick earth. Second one is molding. Third one is drying. Fourth one is burning, and all that. Now we will discuss all these basic steps one by one. Preparation of clay, that is brick earth. There are some major points in the preparation of clay, and we will discuss this. Unsoiling. removal of the top layer, that is earth crust or surface of soil about 200 mm or 2 mm depth. Digging, the clay is dug out after the removal of the soil. The clay is dug out and spread out. Cleaning, then the screening process is started and we clean the digging clay or mud from the earth crust, and we will clean the mud from stones, pebbles, vegetable matters, roots, grass roots, etc. Weathering, the clay is exposed to atmosphere for softening. Blending, clay is loosened and these gradients are sprayed over it and dry vertical mixing is done. Tempering, clay is added with sufficient quality of water and mixed under presence of make it ready for molding. Now the start of molding is started. The process of giving required shape to a plastic clay, we use this molding step. The molding step mainly divided into two categories, that is hand molding and machine molding. The hand molding is now divided in two steps, ground molding and table molding. And the machine molding is divided into two steps, plastic clay machine and dry clay machine. Now hand molding. In hand molding process, bricks are molded by hands, that is manually. A man with his hands mold all the bricks. This is the basic concept of this hand molding feature. The bricks prepared by hand molding are two types, that is ground molding and table molding. In machine molding, we divide in two categories, that is plastic clay molding and dry clay molding. Drying. We use this drying process after molding, and there are two different types of drying, that is natural drying and artificial drying. And in the artificial drying, hot floor dryer and tunnel dryer process is used. Now what is the drying process? When green bricks, after molding, the green bricks contains high moisture and content. So if we direct burns this molding brick, then it will be cracked or distorted. Hence the irregular shapes of bricks are produced. We don't need this. So the mold bricks are dried at first before the burning, and the drying bricks are laid longitudinally in stacks of width, and they become dried. After that they go to the burning process, that is the burning process. It provides strength and hardness to the brick and make dense and durable. The burning process is divided into two categories. One is clamps burning and one is cleans burning. The cleans burning again divided into two categories. One is intermediate cleans burning and another one is continuous cleans burning. The intermediate cleans burning are two types, updraft clean, downdraft clean, and the continuous cleans burning have three categories: bull range clean, Hoffman clean and tunnel clean. Now what are in burning process? The clamps, these are a photo of a clamp. Here the brick and the fuel are laid in a parallel ratio. Total height is 3 to 4 meter, trapezoidal in shape, and fuel thickness is 70 to 80 centimeter. Continuous bull range clean, underground or partially projecting. The first, in this inner brick wall, this is a picture of continuous bull range kiln, how it works. It's a cycling or chain process. In the first chamber, the bricks are loaded, second empty, third is unloading, fourth is cooling, and also fifth is burning, and sixth is preheating. There are some basic steps that the continuous bull range kiln follow for burning a brick. Now, manufacturing of bricks, that is by continuous Hoffman kiln. This is a basic picture of continuous Huffman Kim, and each chamber is main door. This is communicating doors, fuel chimneys, and all that. Now, what the chamber do, we will discuss. The first chamber load all the brakes. 2 to 5 is heating, or you can say 2 3 is preheating and 4 5 is exact heating. 6 and 7 is burning. 8 to 11 is cooling and then unloading, and these are the main doors. Okay. Now, testing on brakes. By testing, by doing some test on the bricks, we can say that this is a good quality of a brick and this is not a good quality of brick. So what kind of test we do? The first of one is water absorption test. This is the formula by which we measure the water absorption test. The water absorption should not be greater than 20%. At first we poured a brick in at first we measured a constant mass of a brick in dry, that is in the dry wet, and we poured the bricks in water. After 24 hours we again measured, and by using this formula we can say that how much the water consumed by the brick. If it is greater than 20%, then it is a not good quality of brick. And another test of the bricks are efflorescence test. The presence of alkali in bricks is harmful, and they form a gray and white layer on the brick surface by absorbing moisture. And if a brick is immersed in 24 hours in water and whitish layer is not visible, then the alkali is absent from the brick, and if the alkali is absent from a brick, then it is a good quality of brick. Hardness test. In this test, scratch is made on the brick surface with hard thing. If that doesn't left any impression on the brick, then it is a good quality of brick. Size, shape and color test. Randomly chosen bricks are measured to know the variation of size as per standard. Bricks are closely viewed A good quality of brick should have a bright and uniform color throughout. Defects on brick. Overburning. If we overburn a brick, then the brick loses its shapes and we produce a irregular size of brick. Underburning. Pores are not closed, hence weak. The the brick should be weak. Bloating. Spongy. Swallows mass due to excess of sulfur. Black core. Bituminous matter or carbon present in the brick. Efflorescence. White patches due to alkali leaching out. We don't need these types of thing in our brick. Chuffs. Deformation occurs if rain, water falls or hot breaks. Checks. Lumps of lime causes volume changes by absorbing moisture. Spots due to sulfide, dark surface, spots on surface. Laminations. Entrapped air in voids of clay form a lamina on the surface. Special type of bricks. Heavy duty bricks. Efflorescence nil, water absorption less than 20%. Uses bridges, industrial foundation, multi-story building. We use heavy duty bricks. This is a different type of bricks. For some special purpose, we build this type of bricks and we use this type of bricks. Burnt clay efflorescence bricks. We use in partition walls, light structures, and the area of each formation should not be more than 500 millimeters square. And another special type of bricks are bricks clay hollow bricks, contains cavity blocks, reduce transformation of heat and sound. Refractory bricks, it can resist temperature of 1700 degrees centigrade. Water absorption is 4 to 10%. These bricks are burned for longer duration. Alumina silica content is increased, lime is decreased. To produce these bricks, we decrease the proportion of lime and increase alumina and silica. The refractory bricks are divided into 3 types, that is acid bricks, basic bricks and neutral bricks. Thank you very much for giving me patience in my presentation. Thank you.